Okay, resultant force and acceleration. There are constant force and there's contact force and non-contact forces. You need to know the different types. That's kind of the gist of it. I know there are a few questions out there, but yeah, we will go through that in a bit. So resultant forces is just a single force that has the same effect on an object. And usually if it's opposite, you're going to minus these forces. If it's the same direction, you're going to add these forces together. That's how you figure resultant forces. So you can see here, it's only separated with horizontal and vertical. Horizontally, we see that there's 500 on the right, 200 on the left. Resultant force, minus them together because they're opposites, giving you 300. Vertical, 800 on the top, 800 on the bottom, minus them gives you 0. 0 resultant force vertically. So horizontal resultant force left is 300. This one's pretty simple, shouldn't be too difficult with resultant forces. Distant time graphs, this is, I think, a bit more focused on triple sciences, but I think both combined also has to do a little bit of this, but more focus on triple. Distant time graphs, generally, this is the same kind of throughout distant time graphs and velocity time graphs. Distance time graphs, the slope will essentially be the velocity because it's just distance over time. If it's a straight line, we will know that this is a constant velocity. If it's curved, it's accelerating because the velocity is increasing as you go up. To figure out the equation, it tells you acceleration is velocity over time. Velocity time graphs, very similar. Velocity over time, if it's straight, it's going to be constant acceleration. So be careful with this. Distant time graphs, slope is velocity, straight line is constant velocity. If it's velocity time graph, straight line is the slope is acceleration, and the slope is if it's straight line, it is a constant acceleration. The thing you probably usually need to be able to figure out is the velocity sometimes. So if you want to figure out the velocity in the distance time graph, if it's curved, draw a tangent. If it's straight line, you can just figure out the gradient. If it's a velocity time graph, if you're trying to figure out the acceleration, you're gonna just figure out the gradient by using change in y over change in x again, same thing. If you want to figure out the distance using a velocity time graph, there's a way to do it. And that's figuring out the area under the line or the curve. So if it's a straight line, it's a constant velocity, a constant acceleration. That's going to be really easy because it's just the area of a triangle. However, if it's something like a curve, like you see in that horrendous box in the bottom right, you do not need to figure out the area under the curve. That is extremely difficult maths that I struggle to do. So you don't need to figure that out. The thing you will figure out is just figuring out the number of squares within the graph, and you'll be able to figure it out. Just counting the squares. Don't need to figure out the actual area. It's just an estimation. That's all you need to know with resultant forces and acceleration.